So our proximate concern at Astrojet Systems is to create fusion energy systems for space. However, what we'll also be working on is light speed propulsion. We'll also be trying to develop a sort of warp drive using fusion energy, whereby we combust the fusion in the deuterium and tritium. We fuse the tritium and deuterium, in a combustion chamber, and then drive the exhaust out through a linear accelerator, so a linear particle accelerator of the exhaust. This will accelerate particles to light speed, and hopefully the energy density will be sufficient such that it does indeed propel the craft via Newton's third law to light speed, right? So we're ejecting this very large energy density, this very great energy density of fused material through a linear accelerator of a combustion chamber, all lined with magnetic fields. Linear accelerator obviously utilizing magnetic fields likewise, and then the exhaust will have this very high energy density. And I predict that even in the exhaust, actually what you'd be creating is very tiny singularities or even very minute black holes, and this would also count as a sort of Kugelblitz engine, since these black holes would evaporate away very quickly, releasing yet again more gamma radiation, and propelling the craft to light speed. And so this is a very intriguing idea. This is like technology that I think is some way off. I think the fusion reactors in space idea, that's something more closely approximating what we're capable of doing at present. But then again, of course, with Astrojet Systems, what we're attempting to do is push the boundaries of what's possible to do at present, and to really investigate deeply the possibilities surrounding things like nuclear fusion, light speed propulsion, and so on. And ultimately to try and get experimental devices launched into space. And this is, very much what I'm trying to do with our first project, the Omega project. The project to bring fusion energy to space and transmit that energy back to Earth via microwave radiation. And that's what we're concerned with mainly at the moment. But developing fusion systems for light speed propulsion also entails that we'll be able to develop fusion systems for speeds slower than that. So we'll be using starships powered by nuclear fusion propulsion to navigate within the solar system, and this will open up the solar system then as a venue, as a bed of resources that we can then access, and we can access it readily and easily without having to spend months and months on end traveling through space with conventional rockets. And also for rocket technology here on Earth, we may well end up using fusion propulsion to get our machinery into space, our rockets into space. At the moment, of course, a rocket is 90% fuel, isn't it? So we've got these gas-guzzling rockets burning kerosene and oxygen and so on. And 90% of the rocket is a fuel tank, of course. And if we're using tritium and deuterium, then I don't know, maybe 1% of the rocket will be a fuel tank. The rest could be a payload. And this makes the rocket equation look really rather different. If you think about the energy densities potentially of different fuel sources, then we could be looking at something very exciting. But this does beg the question, of course, what is the environmental, crucially, impact of nuclear fusion propulsion on the environment? Is it something that would radically heat up the atmosphere? Is it the equivalent to exploding a hydrogen bomb in the atmosphere? And this sort of thing. And you do have to take these things into consideration. And this is very, very important for outlining the underlying risks associated with what our project is attempting to do. So, I'm still looking for people to join me on this project. I think I've got the ideal design for a warp drive down, the ideal design for a light speed engine. We don't necessarily have to go to light speed, we just go very fast around the solar system, of course, as I've said. And these are the sorts of things that we're working on here at Astrojet Systems. The name seems a little more appropriate if you think about like fusion propulsion as well, I think. So big on propulsion, and I should really tie into Rocket Space Limited, shouldn't it? But Rocket Space Limited is about Earth rockets and rockets for Earth. And I think the rockets we'll be building in the first instance will be powered by things like kerosene and oxygen, not nuclear fusion. But yeah, it's very, very important as to think about these things. Space, absolutely ideal for fusion. I think you can do as much fusion propulsion as you want in space without too much hassle and without entailing too many risks. And I think it's with great concern that we think about the environment, we think about the atmosphere, and we think about being very, very cautious with nuclear fusion propulsion within the atmosphere if we do it at all. So yeah, we're looking at things like direct fusion drives. I'll be looking very, very closely at the results of that work. MIT is it, I think, who do a lot of things on things like this, of course. And yeah, we'll be looking at things like that very much, and how to integrate that within space systems, and how to go about constructing larger ships to move around the solar system, and maybe even try and get a sort of fusion propulsion going for rockets leaving the atmosphere. So, I mean, just as a side note, if this were to work out and we got fusion propulsion working in space, we could zip around very quickly in space. It could turn out that really the big hurdle to getting anywhere in space is just leaving the atmosphere, and it is just leaving Earth's gravitational field, and it is just about leaving similar gravitational fields to that. Because I think Mars, it would be a lot easier to jump off and off of somehow. It's slightly less massive. Yeah, and the atmosphere is. No, it has nothing to do with magnetic fields. I was about to make a huge blunder there in terms of my physics thinking. No, it would make a difference. It's just to do with the mass. But yeah, it might turn out that entering and leaving atmospheres is the real challenge of space travel. Yeah, it's like aircraft, isn't it? The biggest challenges are taking off and landing. Once you're in space and you've got something that can move you around in space fast enough, it doesn't seem like it'd be too hard to get anywhere. But yeah, when you're like entering and leaving atmospheres, like that's tricky. Yes, of course. Thank you for watching, everyone. Bye.